Jai Shri Ram, friends. Hope you will enjoy this video. Today's video is all about the different types of operation on the signal. So these operations can be performed on continuous time as well as discrete time signal. So let us start the video. Okay, so there are two types of operation. One is on x-axis, that is time axis, and another is on y-axis, which is nothing but the amplitude axis. So corresponding the operations are say time shifting, then time scaling, then time reversal for time axis. Similarly, for amplitude axis, the operations are amplitude shifting, amplitude scaling, and amplitude reversal. Okay, now let us discuss one by one. First, this is about operations on time. So first, the operation is time shifting, means there is no change in the width, okay, of the signal. For example, if you observe this particular signal, which is a rectangular, or you can say gate signal, in which the xt is some xt minus t naught. You have to perform xt is 2 for the range is minus 3 to 2. Okay, this is minus 3 to 2. So this signal is varying between minus 3 to 2, and the value is constant, that is 2. Otherwise, this is 0. So you have to draw now the xt plus 3 and xt minus 2. So accordingly, we can draw. Okay, how to draw this? Simple method is, if you want to draw xt minus 2, so xt would be replaced by xt minus 2. In this particular signal, you just put or replace t by t minus 2. Okay, so see this, xt minus 2 is equal to, for the range minus 3 to t minus 2 to 2. Okay, now this can be further written as this minus 3 plus 2 less than t less than 2 plus 2. कहने का मतलब है दोस्तों, ये t minus 2 में आप t plus 2 कर दीजिए, so what you are getting is nothing but t. So similarly, on in all these inequalities, you would be finding minus 3 plus 2 less than t less than t plus 2. Hope you will understand this thing. So you are getting 2, which is for minus 1 to 4. Okay, now the range changes from minus 3 to 2, it becomes minus 1 to 4. So this is the xt minus 2, and accordingly the signal can be drawn between minus 1 to 4. Okay, so आप यहाँ पे देख सकते हैं, you can see easily the width of the signal remains same. Means earlier the width was from minus 3 to 2. Okay, means minus 3 means this is 5, the width is 5. Okay, and here also the width is 5 because it is varying from minus 1 to 4. So this is called the right shift, which is nothing but the delay. So ये delay कहलाता है आपका दोस्त. Simply you can draw xt minus 2 and xt plus 3. Okay, there are two types. One is xt t plus 3, and another is xt plus 2. So xt plus 3, how to draw? Again, you just replace this t by t plus 3. Okay, so you just adjust this. So this is an important thing. You adjust it so that you just subtract minus 3 throughout the inequality, means minus 3, okay, and 2 minus 3. So this becomes t now, or you can say minus 6. Now t lies between minus 6 to minus 1. Okay, again, you can see here the range or the width of the signal remains same, means this is 7 in both the cases. So this is xt plus 3. Now this is called advancement or the left shift. Similarly, we can have another example. For example, if you have to draw y, which is xt plus 5. Now this is xt, which is given in the problem, that like this. Okay, this is xt. Now you have to draw xt plus 5. So just do one thing. T plus 5 means in this particular signal, you just replace this signal by xt plus 5. So t plus 5, it would be shifted on the left by 5 units. Okay, so यहाँ पर सबसे जो shortcut है दोस्तों, shortcut is like this. You can say this, all these values, minus 3, minus 2, minus 3, 0, 2, 4, all these values would be shifted on left by 5 units. तो आप इसमें क्या करें, इसमें आप जो प्लस है तो माइनस 5 कर दी, तो माइनस 3 माइनस 5 सब में आप सब्ट्रैक्ट कर दीजिए, माइनस 2 माइनस 5, 0 माइनस 5, 2 माइनस 5, सिमिलरली 4 माइनस 5. तो अगेन यू आर गेटिंग अ सिग्नल which is left shifted, which is advanced. Similarly, you can draw the signal for xt minus 4. तो यहाँ पर जो important चीज है दोस्तों, the important thing is that you have to adjust this argument such that the signal gets shifted to either right side or left side. For example, in 2t minus 4 case, you just shift the signal from initial position to right position by 4 units. Okay, so accordingly the points coordinate would be changed. This is 1, 2, 4, 6, and 8 because I've just told you the method. Okay, so you can check this. Now next is time scaling. Now what is time scaling? In order to understand the time scaling, we do one thing. We just say x is equal to xt and say let it be yt. So you can say this x alpha t. Okay, so this alpha is the conversion factor or scaling factor, you can say. Okay, for example, if you want to scale a function which is x is equal to 2, otherwise 0, for the range minus 3 to 2. Okay, initial जो मैंने भी signal थोड़ी देर पहले लिया था, the same signal I am taking right now. Okay, in this particular case, you have to scale this signal. Now, in case of scaling, the width of the signal gets changed. In this scaling factor is nothing but, say, if this is xt, if this is xt, now you have to calculate the value of x2t. Okay, so in this case, alpha is equal to 2. Okay, because alpha is greater than 1, then you can say x2t is 2, or you replace this t by 2t in this particular inequality and adjust this so that you have to divide the inequality by 2. So you are getting minus 3 by 2 less than t less than 1. Okay, otherwise it is 0. So what we are observing, this minus 3 would be divided by 2, and this 2 is divided by 2, so it becomes 1. Means finally the signal width is compressed. So this is nothing but the compression of the signal. Okay, so you can easily observe this thing. Now in case if you want to draw the signal as xt by 3. Okay, so you are dividing this signal by 3. In this case, alpha is equal to 1 by 3, which is less than 1. In that case, the signal would be expanded. Okay, how? Because you are replacing t by 3. Okay, so in this inequality, you just see this one, minus 3 less than t by 3 less than 2. So in this case, what you are observing is this: if you are adjusting this as a t, so you have to multiply the whole inequality by 3. So you are getting the final range as minus 9 to 6. So this signal ranges between minus 9 to 6. Okay, so width is enlarged or expanded. Okay, similarly, we can have other examples also. Suppose this is xt, you have to draw x 4t. So this alpha is equal to 4 means the signal would be compressed. Okay, 1/4. जो आपके जो इनिशियल पॉइंट्स हैं उनमें आप डिवाइड कर दिए 4 से, तो -2 divided by 4 -1 divided by 4, accordingly you can get the signal like this. Okay, you just see this, the signal would be looking like this. Okay, as you can see here, this is the final signal. Okay, and similarly for t by 2 you can adjust the value. Okay, t by 2 means you have to multiply the initial signal points by 2. Okay, तो -2 देखिए, -2 से 4 हो गया, -1 से -2 हो गया, ये 1 से यहाँ पर 2 आ गया, बिकॉज वी आर मल्टीप्लाइंग दिस सिग्नल बाय पॉइंट्स बाय 2. ओके, and this 2 would be 4. So this signal would be looking like this. So you can observe this. Okay, so this is the way. Now third is time reversal. How would you define time reversal? Time reversal is nothing but y is equal to x alpha t. Okay, now if you just do the time reversal, you just holding the signal with respect to y axis. Okay, how? This x is equal to 2 for the range -3 to 2. Just told you about the signal. Okay, otherwise it is 0. Now if you want to draw x minus t, so this is nothing but the folding. So folding says you just replace t by minus t. So the inequality range becomes -3 to 2 with minus t. So adjust this. Okay, you just multiply this with minus 1. So inequality sign would be changed. Means less than would be replaced by greater than. So final range would be t greater than -2. So finally, I can say the signal would be just folded about y-axis. So this is time reversal. Hope you understand this. Similarly, we can have another example. You can see here, this example shows initial signal xt, as you can see here, and yt is to be converted into x of minus t. Means this signal would be reversed, or reversal, time reversal would get me this folding of signal about y axis. So x and y जो आपके आपके पोर्शन है वो इंटरचेंज हो जाएंगे. As you can see, this brown portion would be on negative side, and this blue portion would be on positive side. So you can easily understand this thing. Okay, because you have to replace t by minus t. Similarly, you can have another example like this. This is your xt, which is having a slope of x 4. You have to calculate the x minus t. So what we are doing, we are just folding the signal with respect to y-axis. So the signal would be like look like this. Okay, so this is the one thing which you have to understand. So this is xt, which is 4 t minus 2. Okay, so x minus t would be 4 of r t minus t minus 2. So this is the ramp signal, which is shifted ramp on the left side. Okay, now similarly we can have the operations on amplitude side also. Okay, so let us understand what is amplitude shifting. Amplitude shifting is nothing but the shifting of amplitude by upshift or downshift, you can say. For example, if there is a signal xt, if you are adding some constant value to the signal, you are getting the upshift. Means xt plus 2 would get me upshift. Similarly, xt minus 3, suppose, then that would give me the value of downshift. Okay, suppose this is the initial signal, as you can understand here, this is the initial signal, and if you want to convert this signal to xt plus 2, just see this one, this is xt plus 2. Okay, so what we are doing, this is xt, and xt plus 2 would be nothing but you have to add a constant term like this. This is the constant value plus 2, which is to be added to this signal. Okay, so all the points would be shifted by 2 units on the upper side. Okay, so you can see here, this minus 2, this value would be on positive side, this 2. Okay, minus ये, and this would be, see this -2 का जो value होगी, that would be shifted by 2 unit. Okay, so this signal would be shifted like this. Okay, on 0 this value is 2, and 2 plus 2 would be 4, and similarly at x is or t is equal to 2, this would be 2 plus 2, means 0 plus 2, that would be 2. So this is how you convert this xt in xt plus 2. This is nothing but upshift. Similarly, you can have downshift also. Xt minus 3 would be like this. Okay, xt, this is xt. Okay, now if you want to draw this x, this is 3 plus, now you have to subtract 3 with this particular sign, then you would write that signal like this. Okay, all these coordinates would be subtracted. Okay, this 3 would be subtracted from respective coordinate. For example, at -2 the value 0, so 0 minus 3 would be -3. You can see here. Similarly, this is 2 at 0, and this would be -3, so 2 minus 3, that is -1. See this one, and similarly this is also -3. So accordingly, this is the downshift. Similarly, you can have another example of sinusoidal wave, and this value is 3 sin omega t, and this is plus 2. Okay, so this whole sinusoidal signal would be shifted upwards. Okay, so this is another example. Similarly, you can say amplitude scaling. What is amplitude scaling? How would you discuss amplitude scaling? Okay, so y is equal to kxt. So the xt is the scaling, k is the scaling factor. If k is greater than 1, you can say y is equal to 2 of xt. This is nothing but the amplification factor. Okay, if k is less than 1, you can say y is equal to 1 by 3 into xt, means this is attenuation, means the signal amplitude would be attenuated. Okay, now see this particular signal in which I am just performing both the operation. One is amplification, other is attenuation. So this is a op-amp circuit, for example, to illustrate this amplification, and similarly this is the circuit for the attenuation. Okay, so accordingly you can see the attenuation and amplification. Now how would you attenuate or amplify? See, this signal would be multiplied by 2. Okay, so accordingly the values would be multiplied by 2. So this is sorry 3. So 3. Okay, 3. So corresponding values would be multiplied by 3. So suppose this is 2, then 2 into 3, that is 6, and 4 into 3 would be 12. So this is how the signal gets multiplied. Otherwise all values remain same. Okay, because this is 0, so 0 into something would be 0. Okay, otherwise the finite values would be multiplied or amplified. Similarly the next one is y is equal to x by 2, means the signal would be attenuated. तो अब यहाँ पर वैल्यूज क्या हो जाएंगी, इसमें डिवाइड कर दीजिए 2 से. ओके, तो 4 would be divided by 2 means 2, through 2 would be divided by 2 means 1. Okay, accordingly the signal would be attenuated. And finally this is amplitude reversal. Now how do you define amplitude reversal? It means you just negating the amplitude, means minus of this, means folding with respect to x-axis. दिस इज एम्पलीट्यूड रिवर्सल. तो आप देख सकते हैं यहाँ पर, देखिए ये सिग्नल वाई एक्सेस के अबाउट है, तो ये यहाँ पर इसमें एक्स एक्सेस, तो मैंने इसको फोल्ड कर दिया, तो दिस वुड बी नेगेटिव साइड, यू कैन सी इजीली, अदरवाइज द सिग्नल शेप रिमेंस सेम. एंड दिस इज द इन्वर्टर. ऑप एम्प सर्किट से हमने इन्वर्टर बनाया. ओके, okay, just illustrating this example with the help of this op amp circuit. Okay, now for example if you want to revert or reverse this signal, so just see this signal and you just take the mirror image about the x-axis, so the signal would be like this. Okay, so this is one thing which you should remember. Now today's video is up to this point. The next part I will discuss in the next video. Till then, goodbye and Jai Shri Ram.